now we will see what is a cyber physical system and embedded devices. Now, if you look at the, last 20 years, the chip sizes have become small, and there's a lot of computing which can be packed in a very check. It's okay. Yeah, so a lot of computing can be packed into smaller devices. Now, but there are certain security concerns when we come to embedded devices. Now, embedded devices are there everywhere, and they are meant for a specific task. Okay. Now, the problem with such things is, since they are working on TCP/IP as an interface, and they are meant for a small specific task, they don't have much computing power. They're supposed to do a specific task. So what happens is, over a period of time, when they start evolving vulnerabilities, they have vulnerabilities, you actually cannot develop protection mechanisms for them. Okay, so how to address those vulnerabilities becomes difficult over a period of time, and that's why you end up moving those systems out of your environment. Okay. Generally, embedded systems are static systems. So what happens is, once you've written what they are supposed to do, then they cannot take any upgrades. Okay. Take into example a TV which is 5 years old or 6 years old. You get 1 or 2 upgrades, and after that it stops taking upgrade, because the amount of data which is required to upgrade will not be taken over by those TVs. What happens is, they become very huge attack vectors in your environment. Organizations connect such devices to their main network, and it becomes a source of vulnerability into their systems, right? Okay. Then you have something called, then we have network enabled devices. All our systems generally have, embedded systems which have rely on network for communication, because the embedded system doesn't have much computing power. What happens is, it relies on the backend to compute. Okay, so most of the embedded devices have a network interface, like you can see Fire Stick. Okay, you can see IoT cameras which are connected to the internet for enabling their complete task. Such systems are called network enabled devices. And finally, over a period of time, we have realized that a lot of production systems which rely on databases and networks to carry out a task. Okay, so the machine tools become the physical systems which are connected over a network, okay, with a backend which could be in cloud. Such systems make use of IoT, robotics, and sensor networks to create something called a cyber physical system, which is now termed as Industry 4.0. Okay, wherein you have IoT devices, robotics, connected over a high-speed 5G network or a 6G network with a data center which is located in the cloud. So what happens is, and finally, it is, you are rolling out systems without any very low dependence on human beings. Right? Now, what are the elements of embedded systems? Elements of embedded systems are mainly small chips, okay, which are embedded into bigger systems to carry out a certain task. Okay, these embedded systems, as I told you, are potential breach points for infiltration into bigger cyber physical systems. Okay, we must have heard of Tesla car being taken over by hackers, electrical vehicles will be taken over by hackers. Your home CCTV cameras have been hacked by hackers. Why? Because their embedded systems have very low security measures, and vulnerabilities are pretty huge. Okay. Cyber physical and embedded systems also go into a lot of bigger picture in self-driven cars, in complex systems as UAVs. These are specialized systems used in non-contact warfare. Okay, and this complete UAV is nothing but a embedded system. It's complete. So many systems are working. Navigation is there. Weapon platforms are there. Engine control is there. Communication systems are there. They're all embedded devices packed into. This is a perfect example of a cyber physical system which is relying on a network to carry out a task without a human intervention. Right. What are major security concerns for embedded devices? Flashed on the slide, CPU. CPU is very small, it cannot handle much power. Very limited network capabilities. It communicates on a particular protocol on a particular port. Can't handle encryption well. Patching may not be available. If there's a vulnerability, how do you patch them? Okay. Ranges are limited, so it has to be near some network. They are of low cost. Quality is the issue. Security by design is not implemented. How do you overcome? You carry out a continuous attack surface evaluation. Always evaluate what is the attack surface like. Segment such networks wherever these devices are. These networks, as of now, in present condition, needs to be segmented. You have to bind the device to wherever it is, whichever network port it is connected to, so that no other device can replicate it. You have to implement firewalls to filter the system. You have to carry out manual updates. You have to use wrappers. So if the initial protocol is insecure, you wrap it in a secure protocol. And that is what is being used in the industry as of now. And last is you have to monitor such networks. So if you are in the OT system, Manish is not there today. Otherwise, he would have given you a good example. He would have given you a better insight. You have to monitor such systems continuously. Okay, then we come to architecture evaluation of applications. Now, microservices is, erstwhile, once we used to develop, systems, how we used to develop systems was, okay, there's the client who needs access to an application. You have an application, which he accesses either on web or on a software. This application will have one application tier and one database tier. So anything which you tell the application to do, it will execute the code, fetch from database, and send the result. But now with a distributed architecture, wherein on the internet, I am doing something, I'm providing a KYC service, right? Somebody is providing me cloud, somebody is providing me KYC service, somebody is providing me payment gateway, somebody is providing me, software as a service, and I want to integrate them all to make an application. So what happens is I take their services and develop my application, right? This is possible because of an architecture called microservices. What happens is a bigger application is broken down into smaller application, okay? And then it has its own database. And when whatever task is required is driven by something called an API. And further by a API gateway. This is the general architecture of microservices. That means if tomorrow I have to make a change to this part of the architecture, I can just change this. It has got no correlation with the second microservice. Okay. And that's why if you have noticed, applications today can be changed very, very frequently. If you look at the Zomato application, I'll give you a small example of the Zomato application. If you look at the Zomato application, right, there is going to be a, there's so much happening, right? The carnival pages come, okay, you can log in. So somebody needs to log in. So login has an API. This will be a login API. Okay. Then this will be a KYC API. This will be the dining API. So what happens if you want to make changes to the login sequence, you only make changes to the login sequence. You do not need to go back and rebuild the application, which used to be called a monolithic architecture. Now you have something called service-oriented architecture, and microservices are part of something called a service-oriented architecture. Okay, right. So microservices are controlled by something called a API gateway. API gateway is nothing but a gatekeeper. Gateway, right? It's a gateway. So if say I am a client, I want to do login, okay, the API gateway will ask you to log in. If I want to do KYC, it will redirect me to the KYC function. If I want to buy something, it will take me the buying microservice. If I want to exit, it will take me to the exit microservice. And if I want to update my profile, it will take me to the update module. Now, what happens is that the API gateway controls what kind of input the client can provide. And what is the security for API gateways? Again, input validation. Okay. So input validation is validating what inputs are received from client. Is this tunnel HTTPS secured? Whatever we have done till now, okay, whether it is transport security, whatever security features you have generally applies now to the session between the client and the API gateway. Okay, that is the concept of microservices. The next I'll say concept is something called infrastructure as code. What is infrastructure as code? Now you are on cloud, right? What is cloud? Cloud is nothing but a hardware sitting behind a software. So you can interact with the software plane to generate some kind of hardware. Now, earlier in on-premise infrastructure, you had to buy a server, fix it, wire it, network it. Today, you just go on the cloud and say, I need a 2 GB server, 2 MB RAM or 8 GB RAM, i3, and you just specify that, okay? And the server is there. Now you can do it manually using a web-based architecture, or you can write certain pieces of code and just provide it to the software layer. It will generate that infrastructure for you, generally written in YAML and JSON. Okay, you write certain piece of code that I need a server, 2 GB, processor, there's a format in which you write, and then you write everything in this code. And tomorrow, if you want to, create a replication of the existing infrastructure, you just execute this code and your infrastructure is ready. This is called nothing but infrastructure as code. Okay, clear? Any doubts? Please let me know. Okay.
Sir, YAML is a set of codes.
Yeah.
YAML, is it a set of codes in some programming language or something?
YAML is not a programming language. YAML is a notation. It's not a programming language. YAML and JSON are set of instructions. It's a derivative of an XML language. Okay. YAML is a data interchange language. Basically, I tell you that there is a particular format. Okay, server, 2G server, processor, i3, something, but it has a certain rules which you have to follow. Okay, and the moment you push it, it just executes. It's not programming. It is not programming. It is a file in which you have sequence of telling what you need to do.
So it's kind of a template we'll be filling and then we'll push it.
Yeah, it's a template. It's just a template, and you can do it in YAML or JSON. Okay, and now you can also write it in a language called Terraform, which you can use to push it for multi-cloud. So you write it in YAML, convert it into Terraform, and push it to either Azure or AWS or GCP or anywhere else.
So in case pushing to the multi-clouds means, sir, I can push it to multiple clouds at the same time.
Multiple cloud? No, not at the same time. The fundamental is the same set of instructions. Certain changes you can push it to Azure also.
Okay, got it.
I have physically not used Terraform. I just know the. I've worked on JSON and the YAML, but I've not worked on Terraform because my hands-on practice is only on AWS. So I've not done it, but I understand the concept because, of course, these are all interchangeable notation. These are all notation languages. These are templating, basically templating. So what happens is once you use Terraform is sitting on top of YAML and JSON, interpreting it and creating formats for Azure and AWS and GCP based on the interrelation. That is the fundamental, right? So you can, whether you can push it simultaneously, maybe you can, but I don't know that, right? Maybe I'll have to do a little bit of research, right? But generally, what happens is, what you do is, as a business continuity, measure. Say your primary is on AWS and it's running on AWS, and your BCDR is on, say Azure, right? So obviously, if I have programmed it in such a manner that if AWS fails, my Azure should take on. So that would be Terraform ready, and I push the Terraform, and it's maybe within minutes, 10 minutes it takes generally to have the entire infrastructure ready and working. So that is the BCDR arrangements generally. Right. How do we achieve virtualization? Virtualization is nothing but basically making use of the unutilized hardware. Once you have a hardware, okay, and you run the operating system on top of it, your lot of hardware might get wasted. So what you do, you virtualize the hardware. So you have the hardware, okay, you put something, a middleman called hypervisor, okay, and then on top of it run multiple operating systems so that your entire hardware is utilized. Okay, so basically hardware utilization gets better, right? That is the simple concept of virtualization. Now there are two kinds of hypervisors. There are type 1 and type 2. What is type 1? Type 1 is something called bare metal, wherein the hardware, on top of the hardware sits the hypervisor, and then on top of it you can have multiple operating systems. Now this gives you better control because you have direct access to the hypervisor and the hardware. Generally, cloud service provider, they work on this model, or like I work with my clients, we do a lot of bare metal, hypervising, wherein we buy the hardware, put VMware, and we utilize four CPUs for Active Directory. We require 4 CPUs for their ERPs, and we buy 16. We calculate the cost, whether going on cloud is cheaper or going on on-premise is cheaper. We generally see that going on-premise is initially very cheap, right? Whereas going on cloud is initially very costly. Monthly cost reduces, but overall yearly cost might be very high. So we buy a system and say, okay, this life is 5 years. For small clients, we generally prefer being on-premise. Why? Because it's easy to maintain. But for bigger clients, we'll probably not go to if they do not have the capability of on-premise virtualization, we take them to the cloud. It all depends on money basically at the end of the day, right? So type 1 hypervisors are bare metal hypervisors which can give you direct access to the hardware. They are also called type 1. Type 2 hypervisors are which we use in our daily homes, right? I have a server, on it sits a operating system, on top of that I put a hypervisor. What is the best example? VirtualBox, VMware, right? So these are ones which we can use on our own computers, and then on top of it, you can have 1 or 2 OSs. Beyond this, it will crash down. Okay, so this is called a type 2 hypervisor, right? Because of this, if you see this hypervising, what happens is you have a lot of elasticity. Say tomorrow you need 1 more CPU, you just take this particular architecture. You need more, you take more, you take more. So there is horizontal and vertical scaling possible in cloud in real time. Okay, and that's why cloud for availability is a good strategy. Okay, the moment even cloud service providers have a problem of end of life and end of service life. What happens? The hardware which is sitting, it gets over because it is now this hardware is being used in real time by so many users. This hardware starts wearing down. Okay, and the normal life may not be as high as in an on-premise environment. So what happens is people start using this hardware. The end of life is pretty quickly. So cloud service providers have to continuously rotate the hardware. Okay, then there is a lot of virtualization software, right? Which we use. We use VirtualBox, we use VMware, we use Citrix, okay, for daily virtualization needs. Okay, but they cannot make changes to the host operating system. So if I put virtualization software like VirtualBox on top of Windows, they do not change anything. They do not have direct access to the hardware. They have access only to the operating system. Okay, such kind of activity is called containerization. Okay, now over a period of time, networking has also become virtualized. You do not have to manage the network devices directly. Erstwhile, 10 years back, I had friends who were sitting whole night, whole day managing VPNs, managing routers, downtimes, uptimes. Now that era is there. I see them still sitting and doing it, but it is being replaced by something called virtualized networking, where you do not have to exactly go down to the device level or the router and maintain it. You have a software plane on which you interact, and you just ensure something called the quality of service. Okay, so you basically tell the client says, look, I want this quality of service at all times. How you do it, it's up to you. So now I have a lot of network resources for my network, and I need to that particular quality of service for a client. I maintain it through a software. I basically tell the underlying hardware what they need to do by not directly interacting with the hardware. 10 years back, we were interacting directly with the routers of the ISPs because we had taken that port from the ISP. So we were directly engaging with the router and configuring if a port is going down or if a network is going down. But that is being replaced by virtualized networking. And today you have software defined everything. You have software defined infrastructure, you have software defined software, you have software defined security, you have software defined infrastructure. So everything is basically controlled with a software plane because the complexity of hardware is no more required, because you can now control, there are so much of software which has been built so that the complexity of handling the hardware doesn't exist anymore, and you can manage it using a software. And that's why it is called software defined everything. You can define software defined storage, software defined network, software defined quality of service. So a lot of things you can define in using software defined modeling, right? What are the concerns when you are in virtualized environment? The operating system. Okay, we discussed that, this is the hardware, this is the hypervisor, and on top of this there's a machine on which OS is sitting. This is infrastructure, so you have to patch the OS. Nobody else is going to patch the OS. Patching of hypervisor, patching of hardware is responsibility of the cloud service provider, but your responsibility is to patch the OS. It's a shared responsibility model. Okay, stability of the host is the responsibility of the cloud service provider, because you don't have access to the underlying hardware. So stability has to be provided by the cloud service provider. Backups and archiving, your problem. It is not his problem. Cloud service provider is not worried about backups. You have to back it up. VM sprawl, though said, not experienced. VM sprawl means from one VM, I can go to the another neighboring VM. Heard of, not, I've seen it on YouTube, somebody doing it, but not reported in AWS or GCP environments. Privilege creep, very easy. Why? Because you have a lot of cloud accounts and you might forget, because there's so many accounts you have to manage. There might be some users which will have additional privileges which you are not able to monitor. Misconfigurations in cloud is very common, and because of which a lot of security breaches take place. And another thing is VM escape. VM escape is escaping from your VM and trying to access underlying infrastructure of the cloud service provider. Okay, so these are the security concerns on the virtualized environment. Okay, now one of the major concern in cloud is, yes.
Sir, this privileged creep and privileged escalation, are they both similar?
What?
Privilege creep and privilege escalation, are they both similar?
They are similar. Escalation is, when do you escalate? Escalate, somebody does, right? How do you escalate privilege? Escalate privileges, I have gone inside and now I am escalating my privileges. Okay. Privilege creep is, you were yesterday given user rights, then you had some requirement and you were given admin rights and somebody forgot to take your admin rights away. Creep has happened. Okay. Escalation is, I'm doing something to escalate my privilege. Escalation is an active tone. I'm an hacker. I'm trying to escalate my privilege. Creep is happening on its own. You gave me some rights and then you forgot to take it away. Creep happened. Slowly. Okay.
Roger, sir.
Yes, Samrat. Good question, please.
Sir, quick question. Yeah. So this was a very recent discussion I had, but then I thought that since we had the topic and we could probably discuss a little bit about it. For example, there are administrators and they've been assigned a task to, let's say, update patches on a Unix system.
Yeah.
One of the risks that I see is that they should never be able to see the whole inventory. So where does that get covered here? And that's like a very standard thing which happens, right? I mean, I hire a Linux administrator, so I would give them access to the entire inventory. So
No. Where
is
you're
it
talking
like,
about cloud? Are you talking about cloud or on-premise?
yeah,
Because
yeah,
if
it's all
you're in
cloud. Yeah.
so in cloud, you can have very, very, I can show you AWS right now. You can actually write piece of code as to what the administrator can do. Now that is upon your maturity. Are you aware? Because AWS needs hands-on requirement, right? So what happens at times as security managers, we are not very hands-on with a lot of things, right? So I went to AWS. When I did AWS certifications. In AWS, you can actually define what the administrator can actually do. You can go very minute. You can amend his complete access JSON file as to what he can. He can only generate a server which is not more than 2 GB RAM. You can do that.
Okay.
That is the granularity where you can go on AWS and on Azure and on GCP. I can show you right now. Okay. You can go to exact AWS has a lot of granularity. So that what happens is when you give now how security gets violated. You are the administrator. You have to sit down, research, find out that granularity, and then give it. What you do? Oh, come on, yeah, I trust him. I give him access, right? I give him administrator access. What happens is shadow IT. Okay. Right? I was in Aquarius, right? The Samrat. I had
Yeah.
access to everything. I could have easily built them for almost $1 million. They wouldn't have come to me. It was just my integrity and CISSP which saved me. I said, these guys don't know anything. Right? I could have easily built them for $1 million and could have walked away because I had administrator rights to everything. And I was a CIO, CISO, everything. But what I said that, to ensure that, I got Shweta in and I told her that please ensure that I don't go, and create this shadow IT. Because there was no one to check.
Yeah, that's interesting.
I was the AWS architect. I was a CISO. I was a CIO. So what happens is in bigger, I've seen this shadow IT problem in places like Nike. One of my friends is a forensic investigator in Nike. Okay, and these guys were running a huge shadow IT to the tune of $10 million inside Nike. 3 guys got fired, but they went away with a lot of $1 million.
A lot
I
of
guess.
digital transformation projects get sold like that, right?
Right. Yep. So now what has happened is, with Zscaler at least, you can pick it. And if you are good in cloud, it's very easily traceable. It's very simple. You can go and define which regions the cloud is allowed to be. Say if I'm in the granularity in cloud is awesome. Means if someone tells me you want to be a CISO, I say, are you on a cloud or on-premise? And they say cloud, I'll be more than happy. I'll be so happy if I'm in cloud. I have so much of control over the environment. On-premise engineering is very, very, very difficult. Hybrid engineering, very, very difficult. I deal with hybrid engineering daily. Okay, and it takes my headache. It's just now my team was sitting on one of the client side and doing something. So if you tell me to go on cloud, if you have the budget, I would love to go with a cloud first organization, to be very, very frank, because I can control it very, very granularly. I can monitor each and everything. There's so much of integration is so easy. I can we set up a SOC in 6 hours. We set up a cloud SOC in as low as 6 hours, and everything, entire feeds were coming, right? Everything in front of us. So what I'm trying to say, cloud very functional, but problems are very high, right? If you do not have a mature cloud team, the bills will spiral. It just spirals out of control, right? So you have to watch for server sprawl. They said it is possible. I've not seen it, to be frank. Shadow IT is one of the biggest concerns if you're on cloud. Please audit your resources at all times. Okay, otherwise you'll have because developers will say, oh, I can create some stuff here very easy. I've got the administrator access. I can do a project for myself and nobody will come to know, right? It's as simple as that. So you need a lot of audit issues in shadow IT. Great. Okay, now the next concept is of containerization. Now, what happened once you have your hardware? Okay, you have a lot of hardware. Okay, and you are running your hypervisor. Okay, and now you're saying, if I want to run an application, please give me a VM. Okay, on which I have to maintain the operating systems, the libraries, the binaries, and the application. Right? This is how my system will work. Now I say that every time, now, if any one of you have been a server administrator, maintaining this server is a pain. It's a big pain. You have to maintain the OS, you have to patch it, you have to, every time, do so many things to keep the configurations right. So you say ki, and on top of it, you need 8 GB RAM minimum, you need 2 cores. You say, why do we need so much infrastructure just to run one small application? We say, let us, if this is your application, it needs binaries, it needs libraries, and it needs certain portion of operating system environment, Linux based or Windows based. Why do you need the whole OS? Okay, so let's generate this environment only for you. So what you do, you create on top of the hardware, you have the hypervisor, and you have a small environment defined by a container, which says, I will not give you full functionality of the OS, but I'll give you all the necessary drivers, libraries, which you require to run your binaries and your application. Now, suddenly you see a web server, which required a 8 GB RAM and everything. Why? Because web server was hardly using 200 MB. Rest, everything was being utilized by the OS. So you need only certain dependencies. You give those certain dependencies inside that container. Okay. You only give those dependencies. Rest all is not required. So you have a shorter, smaller hardware requirement. Such concepts are called containerization. You're taking small container out of the OS, basically. Okay. So you have 3 tiffin, you eat tiffin box. 1 tiffin box is your whole lunch, but you may not be that hungry. You just need the top. So you take the top tiffin box. You don't need this and this. Okay. So that's the concept of containerization. Okay. 2 major containerization, softwares, Docker and Kubernetes. Right. What are the security issues? Now, the moment you take all the functionalities of the OS away, what happens? The security functionalities also go away. So you need to have it develop a security concept for Kubernetes separately, for the Docker or whatever containerization protocol or software you are using. That is the major issue with security. So now everybody's talking about Docker security or Kubernetes security, because you have only certain binaries and applications which are required. You don't require the whole operating system. And then came, why do we need the operating system itself?
So what are we achieving from containerization? As a user or as a provider?
As a user, you are achieving so you do not have to maintain the whole server. Today, if I have to run a web server, and if I have to say, who asked this question? What are we achieving?
Sir, Akhilesh.
Akhilesh. So Akhilesh, say I want to run a web server today, right? So a web server. So web server, firstly, you will write code. You will write code in HTML, CSS, right? JavaScript maybe. Okay, you'll write this code. Okay. Now this code has to run somewhere, right? So you wrote this code. This is the code for web server. Then you write the application code. Application you have written on CISSP, C++ or Python, whatever, right? So what happens? HTML, CSS is the visual interface. C++, Python is what input and output will be taken from here and calculated mathematically. Okay. Say if you are given a username and password, who will compare it with the database? This language is going to compare, right, with the database. And database could be SQL, Postgres, MongoDB, whatever, right? Now, this is your application, banking application. What does the banking application do? First process is opening the web page. Then say, what is the second process? Login. Then third process, show me my balance. All this thing is happening because of this code, because of this front end, and because of this back end, right? Now, if I want to run this application, I need one server. Okay. In that server, there will be DB. In that server, there will be application. And in the server, there will be web server which will run. For web server, I need a server software. What is it? Firstly, the overall Windows server probably I will use. Okay. On top of that, I will run its web server, which is the IIS. Okay. For database, I'll have to install SQL. For application, I'll have to install Python, right? And then I have to maintain this entire server. Got it? Now, this is a pain. This is a major pain. So I say, and secondly, application actually required only 300 MB of processing power of memory. Balance memory is all being taken by the Windows and respective servers. So I'm saying, why do I, why should I should be able to optimize it. So let's say, we'll say optimize. How do we optimize? We give whatever web server, what are its dependencies? Okay, it requires only IIS, right? I'll give you IIS. You require application, what? Python, right? I'll give you a Python environment. Database, you require SQL, right? I'll give you an SQL environment. What am I saving? I'm speaking hardware. I'm sharing that hardware with somewhere else. Huh? That's why cloud is working.
Is it like a platform as a service, or if I get a platform as a service and then I work upon
it is containerization is kind of a platform as a service, kind of. But in platform as a service, you have to define the OS. In containerization, what am I getting is now I can run multiple applications on top of a single OS. What happens now? If I am the service provider and this is my OS, and I can run something called a Docker engine or a containerization engine, and now I can run multiple applications, small applications on my single piece of hardware. That is the concept, nothing else. It is akin to what is platform. Yeah.
So do we need to have certain infra related services to run the multiple application? Yeah.
In cloud, no.
Okay.
In cloud, no. If you can do Dockerization on premise also. See, I'll tell you. If I was say BT, British Telecom, right? I'm talking about BT because I know about BT. So BT had everything on premise. They had a huge data center in Gurgaon.
Right.
Okay, Orange ka BT ka single data center.
Yeah.
75% of server time unutilized.
Exactly.
So what do you do with that unutilized server space? Now you say that, okay, only 25% is being used, right? Let's use the 25%. Rest 75, let's give it to someone else now. Let's run a Docker. Okay, you need this 25. You take this 25. Now let's outsource this and get some more money.
Exactly.
It's optimal utilization of the hardware, basically. That's the point.
Okay, got it.
Okay.
Got it. But Colonel, but many many application doesn't maybe having maybe required a different OS. So how to ensure that that proper OS has been installed to run the application?
एक बार दोबारा मैं किशोर का मैसेज पढ़ रहा था, मैं हंसने लगा. हाँ.
Okay, so maybe to run the application, so we may require the OS. So the OS, on the same OS we can run multiple applications.
You never require for running an application, you don't require OS, and that's why I said, you see, and that's why concept clearing is very important.
Okay.
For running an application, you need only libraries. You don't require OS. तभी तो तेरा Python भी चल जाता, तेरा Python Mac पे कैसे चल जाता है, तेरा Python Linux पे कैसे चल जाता है, तेरा Python, because it doesn't require OS, Baba. The compiler only has to match. It only required libraries.
Okay, got it.
Got it?
Thank you. Got it.
So it only requires the environment definition. So होता क्या है that Python libraries for Windows might have a different configuration set. Is container agnostic of OS? In what sense? Understand. Containers are built for OS. Please understand. See, if I want to run a Docker, why am I running a Docker? I have a Windows machine. Okay. This is my OS. Okay.
Okay.
I want to this is in particular in reply to Samrat. Now I want to utilize this Windows. I know this is a pretty 32 GB RAM server. Okay. And on top of it, I have 32 GB RAM with 16 cores. And the application which is now running hardly utilizes 2 cores. It's a misutilized. So I said, okay, you need 2 cores, right? I will build an application. I'll make a Docker engine here. Okay, I'll make a Docker engine here. Okay. I'll not make a full Docker engine. I'll make half Docker engine. I'll not use all complete resources. I get 50% of the resources. I allot Docker 50% of the resources. That means I've utilized 16 GB RAM. To make you understand, it doesn't happen that way, right? 16 GB RAM, and I've given you 8 cores, right, to the Docker, right? Now on the top of the Docker, I need to run a web server. Okay, chal bhi web server chal gaya. Okay, I also need to run a DB. Okay, chal bhi database chala diya, MariaDB. I also need to run a SQL. SQL chala diya. You see the flexibility. अब यही चीज if you were doing on without the Docker, then you were installing its own libraries into OS. The efficiency of the Windows OS would have gone down. So you are utilizing now the Windows Server as a virtualization platform to specific needs. Now, Docker can run for small applications, not for very big application. It can run for microservices. It cannot run monolithic services. Please understand that. Small services, microservices, छोटे-छोटे application बनाए आपने अपनी environment में चलाने के लिए.
Okay.
They're meant for that. Okay, it cannot run a very huge application. For huge application, you'll have to go back to infrastructure. Okay.
Okay. Got it. Thanks. Thank you.
Yeah, thank you. But I have a quick follow-up question. I don't at the cost of stalling everyone, but then
No, please. Discussions are the best way to understand.
so this is this is something which is very pertinent to what we see in everyday talking to clients and stuff like that. Docker security ka kya ho raha hai and Kubernetes security ka kya ho raha hai. But what I'm trying to understand is, are we and when you say choti application, it's sort of leading me to think ki,
Security is an issue.
most of the applications are being made like that, right?
That's
applications.
Yeah, so that's why in Docker there are two security concerns. One is the security of the Docker itself. Second is the security of the container.
Container, yeah.
Okay, how do you secure the container? And second is how do you secure the application?
So
application security.
Yeah. Right. So are we looking at and this is again, open to others as well. Are we looking at an era where, so one, I keep reading a lot of news and talking to a lot of clients that people are repatriating from the cloud. They want to come back to on-prem. They're talking of that and they're paying egress fee.
Cost. Bahar, nobody is concerned for security. Bahar, everything is about cost. So the cloud cost is unbearable. Let me be very frank.
Yeah.
Today I calculate something. I had a requirement for an SIEM installation for a pretty big client. Okay, I did my maths. If I was buying a SIEM from the cheapest SIEM I find is of
Wazoo.
No, Wazoo is the free only. Half the clients I use Wazoo. And the cheapest is this guy called I'm forgetting his name.
Fortism.
No. It's a company which has been bought by. Wait, let me tell you. So I bought the cheapest I find is them $5,000. So $5,000 is 4 lakhs, right? 4 lakhs, on cloud. And then I calculated. I said, for a Wazoo instance on AWS, a 2 GB RAM bills me around $150 on AWS, right? $150 is how much? Roughly $12,000, right? So 12,000, 8 plus 4, yeah, $12,000, right? I said, this client is my annuity client, right? He is going to be there with me for next 5 years, at least 10 years, right? I bought one single blade second-hand server from Neuroplace, right? And I installed Wazoo on that, and it's running perfectly fine. I have not spent any money.
Hmm.
So
Okay.
for me, on-premise management is much easier than going to cost-wise. Compliance is not. Compliance is of having a SOC. I have a SOC, right? Compliance is not for going to cloud or there are a lot of people. Yeah, compliance on-premise compliance is required for a lot of places. That's fine.
Yeah,
But
the
cost
cost of
is a
compliance actually beats the cost of running because that's unknown, right? Cost of your data exchange with the cloud is unknown.
Yeah.
So my question was actually, are we heading towards a time where we will see companies acquiring really large infrastructure, because now you can containerize apps and build in a way that you just showed.
No, you will.
Actually, ये आपने काफी simple करके बताया मुझे, so this was very very relevant.
Okay, no, you know what will happen? I'm telling you, the cloud providers will give you data residency SLAs. Because it's actually impossible to replicate what AWS have done or what Azure has done. The kind of simplicity that exists in working in the cloud it's actually very good. Okay, security wise, compliance is something which can be met. Okay.
Yeah.
But if in short term, if you look at short term goals, if I am the infrastructure manager, I will say, boss, cloud is too expensive. See, everybody has hidden agendas. If I have come to a company, I have to, I'm getting paid 10 CR. I have to show work, right, boss? So then I evaluate, okay, I can save in next 5 years, say $100 million by not going to AWS, by maintaining, 10 million worth of, one thing is there. What you pay for in cloud, you pay 1/10 on premise. But the operational expenditures reduce like anything. Electricity goes away.
TCO, yeah.
Your cost of what you said, TCO, right? It reduces. No electricity, no HVAC, no maintenance, no shifts. Nobody has to wake up in the night. I've managed infrastructure all my life. I know what a pain it is. Okay. If your data structure is not tier 3, tier 4, rats are roaming around in your cable tray.
Yeah.
Okay, so
No,
let's not get there. So it's a debate in itself, right? Okay, so then you say that, okay, why do you need a Docker also? I said, I don't need a Docker. I just need to run a Python code, right? I'll give you the environment. You don't worry about it. So now Docker as a service. I have removed the complete serverless. You don't worry. You just run the code. Function as a service. You just give me the code. I'll run it. You tell me the code and tell me the environment. Python. Okay. Now, if you go to AWS, there's a function called Lambda functions. For small pieces of code, Lambda can handle very, very effectively. Okay. These are called serverless architectures.
Thank you for watching. Don't forget to subscribe our channel.